Hello students, welcome to our channel. This is Anand Kumar Singh. Today we are going to cover a very important topic related to matrix. As we have learned in our previous class, what is a symmetric matrix and what is a skew symmetric matrix. Symmetric matrix, if we consider a matrix A, square matrix, obviously while I am speaking about symmetric and skew symmetric, the matrix must need to be square type. If A be a square matrix, then it is said to be symmetric. If A be a square matrix, then it is said to be symmetric if its transpose is equal to A itself, and it is said to be skew symmetric if its transpose is equal to negative of A. Okay, it is the definition of symmetric and skew symmetric matrix. Now our today's topic is, if we are given any square matrix, let B be a square matrix, and we are asked to express B as a sum of symmetric, 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 and skew symmetric, MMETRIC, symmetric matrix. Then how it will be possible to express B as the sum of symmetric and skew symmetric matrix? So here we are going to learn a very interesting idea how to express a square matrix as a sum of symmetric and skew symmetric matrix. Now the idea to express any square matrix as a sum of symmetric and skew symmetric matrix is like this. Let A be a square matrix, SQUARE, square matrix. Okay, now let's consider A is equal to half of A plus S transpose plus half of A minus S transpose. It is obvious, as you know, that if you break the bracket, then you will get half A plus half S transpose plus half A minus half S transpose. Okay, and half S transpose plus half S transpose minus half S transpose will be cancelled out, and half A and half A will make completed. Okay, now if we express any square matrix A as the sum of half A plus S transpose plus half A minus S transpose, then we can see from here that half A plus S transpose, if we take its transpose, then half is the number, it will be taken outside, and we have to take A S transpose. And as we know, the fundamental idea of transpose, we can break it like the transpose sign will be shifted from here to here, A transpose, and here to here, A transpose, and it will be S transpose plus, and we know that the double transpose of a matrix will be itself, S transpose will be A, and it is half A plus S transpose. And here you can see the transpose of this matrix is itself, and from the definition of symmetric matrix we have learned, if the transpose of a matrix be itself, then this is said to be symmetric, then it is the symmetric, SYMMETRIC, symmetric matrix. It is the symmetric matrix. If the transpose of a matrix be itself, then it is the symmetric matrix. So the first part of this expression is a symmetric part. Okay, now for the second part, so first part is the symmetric part, it is the symmetric matrix, is SM. Let us consider it as SM, symmetric matrix. Okay, now for the second part, half A minus S transpose, if we take whole transpose, then half is a number will be taken outside, and we will perform the transpose over A minus S transpose. Okay, half, and fundamental rule of transpose will be shifted here, A transpose, and here is double transpose, that is A transpose is equal to half S transpose minus, as we know that the double transpose of a matrix is itself, and taking minus sign outside, we will have half A minus S transpose. And we can see from here that the transpose of this matrix, is the matrix with the negative sign. The transpose of this matrix is the matrix with negative sign, and as from the definition of the skew symmetric matrix, if the transpose of a matrix be the negative of that matrix, then that matrix is said to be skew symmetric. So this part will be skew symmetric matrix. Skew symmetric matrix. So if we are asked to express any square matrix as a sum of symmetric matrix and skew symmetric matrix, then we have to break that matrix as A is equal to half A plus S transpose plus half A minus S transpose. Okay, the first part will be the symmetric part and second part will be the skew symmetric part. From here, we are able to express any square matrix as a sum of symmetric and skew symmetric matrix. Okay, students, next lecture will be on some definitions. And examples. Okay, if this lecture be helpful to you, then please like, support, and share and subscribe. Okay.